80% of our planet's living space is the deep sea. So everything else that you normally think of, from deserts to tundras, to the rainforests and coral reefs, all of that is in the other 20%. But when we look at the deep sea, we often think, what an extreme environment. But I would say it's backwards. They're the normal ones. My name is Peter Girguis. I'm a professor of Organismic and Evolutionary Biology here at Harvard University. When we work in the deep sea, we're dealing with up to 800 atmospheres of pressure. The projects that we're working on in this lab are aimed at taking the technologies scientists have developed for space exploration, or even for oil and gas exploration, and using them to understand life in the deep sea. I actually started off wanting to be an astronaut, but I began to realize what I really like is exploration. Once I started taking classes in marine science, I thought, holy cow. To me, that was a no-brainer. One of our most unique tools, and frankly the only one of its kind in the whole world, is a 20-foot shipping container. We've taken that and gutted it and turned it into a mobile deep-sea research lab. We've built in gas delivery systems, lighting systems, environmental monitoring systems, all sorts of chemical sensors, and in this refrigerated box, we're able to bring animals up from the deep ocean and put them in pressure vessels. No other lab does this as often or as effective as we do. Lately, we've been thinking a lot about the great whales. We know what they eat, and we can collect their poo. We don't know a lot about what happens inside their bellies.
I worked with like human poo and whale poo, and I think this one is by far smells better. Whales go through this beautiful migration, which can be a journey as long as 60 days. Not only are they fasting, but they are actively swimming. They are actively mating. The microbiome, we believe, is doing something very important. They are helping them somewhere, and we are trying to figure out how and why.
All living organisms are essentially electrical machines. That's the basis of life as we know it. Now here's where it gets really cool. Microbes that live in mud at the bottom of the ocean, they can produce electricity. If I put a graphite rod in sediments, and I connect that graphite rod by a wire to another graphite rod that I put up in the oxygen, microbes will actually grow in that graphite that's in the mud and produce electricity.
So right now I am sweeping across a couple of different electrochemical potentials and measuring the current that's being generated by the system.
There is no extension cord that leads to the bottom of the ocean. And sending batteries down there is something we do all the time, but it's expensive. We're excited about this because if we can use electricity made by marine microbes in the mud, as small an amount of electricity as it is, we can run sensors and we can use it to do monitoring and to understand our ocean in a way we never could before. We scientists really are passionate about our science, but we're people like everyone else. And one of the things that's really important to me is to build a culture of inclusivity and synergy. If I succeed in making everybody in my lab better scientists than I am, then I will have made a fantastic contribution to science. I think that's the mission of each of us as mentors.